Outer space, a vast and mysterious abyss sprinkled with light, brimming with enigmas that challenge our understanding. It's a place where the rules we know on Earth collapse, where magnitudes and concepts become incomprehensible to our minds. Today, we'll dive into 20 minutes of facts that will make you question the very nature of reality. Get comfortable and prepare for a mental journey through the most astonishing corners of the universe. The size of the observable universe. The observable universe spans approximately 93 billion light-years in diameter. But this number is merely a shadow of what truly exists. It only includes what we can see, regions from which light has had time to reach us since the Big Bang. Beyond the visible horizon lies a universe that could be hundreds or thousands of times larger. Imagine a vast ocean whose shores you can never reach. Some scientists even speculate that the universe might be infinite, an idea that completely defies our perception of boundaries. Now consider this. While we view the universe as something current, what we truly observe is the past. When you gaze at a star millions of light years away, you're seeing how it was when dinosaurs roamed the Earth. This cosmic delay turns us into archaeologists of the universe, always peering back in time. The largest known star, Scuti. Among the vast catalog of stars studied by astronomers, Scuti stands out as one of the largest. This red hypergiant, located about 9,500 light-years away in the constellation of Scutum, has a radius approximately 1,700 times greater than the Sun. If placed at the center of our solar system, its surface would engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. However, its size doesn't equate to density. In fact, Scuti is so massive because it consists mostly of extremely sparse gas. This means its mass isn't proportional to its volume. There are much smaller stars that are significantly denser and more massive. These characteristics also make its lifespan much shorter on astronomical scales, as it burns its fuel at an accelerated pace. Rogue planets, lonely worlds. In our galaxy, there are planets that wander alone through space without the company of a host star. These objects, known as rogue planets, have been ejected from their solar systems due to violent gravitational interactions. It is estimated that there could be over 100 billion of these planets in the Milky Way alone. The most fascinating thing is that some of them could be habitable, at least in a limited sense. Despite not receiving light from a star, they could generate internal heat through geothermal processes, or even maintain dense atmospheres that trap enough energy to support some form of life. This serves as a reminder that life, if it exists, could thrive in places we can't even imagine. The Fermi paradox and the Great Filter. One of the greatest mysteries of the cosmos is the absence of evidence of advanced extraterrestrial life, despite the overwhelming probability of its existence. This question, known as the Fermi paradox, poses an unsettling query. Where is everyone? With billions of stars in the galaxy, many of which have potentially habitable planets, it seems unlikely that we are alone. One possible answer is the Great Filter, a hypothesis suggesting that there is an extremely improbable obstacle on the path to advanced civilization. This filter could occur before, during, or after the emergence of intelligent life. If it lies ahead of us, it means we could face our own extinction before becoming an interstellar species. Supermassive black holes and their mysteries. Black holes are objects that defy the laws of physics as we understand them. Among them, supermassive black holes like TON 618, with a mass equivalent to 66 billion suns, are truly incomprehensible. These giants are found at the center of most galaxies and play a fundamental role in their evolution. The singularity at their center, where density becomes infinite, is one of the most intriguing points in modern science. We don't know what happens there. Some theorists speculate that it could be a gateway to other universes, while others think it's simply a dead end for matter and energy. What we do know is that their gravitational pull is so strong that not even light can escape, making them the ultimate predators of the cosmos. The Great Red Spot of Jupiter, an eternal storm. For over 350 years, Jupiter has hosted a colossal storm known as the Great Red Spot. This vortex, larger than Earth, consists of gas clouds swirling at hundreds of kilometers per hour. But the most curious thing is that we don't know what fuels its longevity. Why has a storm that should have dissipated within a few decades remained active for centuries? The Moon, an eternal witness. The Moon, our natural satellite, holds an intact record of the solar system's oldest events. Its surface is filled with craters caused by meteorite and asteroid impacts dating back billions of years. On Earth, weather, plate tectonics, and other processes have erased most of our geological past. But on the Moon, there is no atmosphere to erode or water to dissolve its history. If that's not enough, consider this. Without the Moon, our Earth would be a completely different place. Its gravitational influence stabilizes the tilt of our axis, giving us relatively consistent seasons. Without it, changes in the axis could be so erratic that the climate would be chaotic, making it difficult for life as we know it to evolve. Neutrinos, the ghost particles. Despite their elusive nature, neutrinos are fundamental to understanding some of the universe's greatest mysteries. These particles offer a unique insight into nuclear processes in stars and cataclysmic events like supernovae. They could even provide answers about dark matter, as some theoretical models suggest that specific types of neutrinos might be related to this invisible substance that constitutes much of the cosmos. Moreover, neutrinos play a crucial role in understanding the fundamental forces of nature. Their study has led to groundbreaking discoveries, such as confirming that they have mass, something that challenged previous theories. This opens the door to even deeper questions. Why do they have mass? What does this imply for the standard model of particle physics, dark energy, and the expansion of the universe? The discovery of dark energy, a mysterious force accelerating the expansion of the universe, revolutionized modern cosmology. It accounts for approximately 68% of everything that exists, yet its nature remains completely unknown. Some theories suggest it could be related to the properties of quantum vacuum, while others propose it might be a new form of energy we have yet to understand. What we do know is that dark energy is stretching the universe in such a way that, in the future, distant galaxies could move so far away that they become invisible to us. This would mean that eventually, most of the cosmos will be out of our reach, leaving our galaxy as a lonely island in a dark, empty ocean. Pulsars and their impressive precision. Pulsars are neutron stars that spin at extreme speeds, emitting beams of radiation that appear as pulses when observed from Earth. The most incredible thing is their precision. Some pulsars rotate hundreds of times per second and maintain a rhythm so constant that they surpass the most advanced atomic clocks. These cosmic lighthouses are fascinating not only for their regularity, but also as natural tools for exploring space-time. For instance, by studying how pulsar signals are affected by gravity, scientists can test theories like Einstein's general relativity and search for gravitational waves from cataclysmic events in the universe. The Andromeda Galaxy and its future collision with the Milky Way. In about 4.5 billion years, our galaxy, the Milky Way, will collide with its closest neighbor, the Andromeda Galaxy. This titanic event, known as a galactic merger, will be an unimaginable cosmic spectacle. Although individual stars rarely collide due to the vast distances between them, the galaxies will intertwine and form a new structure, possibly called Milkomeda. The most fascinating part is that this collision doesn't necessarily mean destruction. In fact, it could trigger the birth of new stars as clouds of gas and dust compress. However, for any form of life existing at that time, the night sky will be transformed into a chaotic mosaic of lights and colors. The mystery of FRBs, fast radio bursts. In recent years, astronomers have detected strange radio signals originating from distant galaxies, known as fast radio bursts, FRBs. These bursts last only milliseconds, but in that brief time, release as much energy as the sun does in an entire day. The origin of these signals remains a mystery. Some theories suggest they could be caused by highly magnetized neutron stars, called magnetars, while others speculate about the possibility of advanced extraterrestrial civilizations. Although there is still no conclusive evidence, each new detection of an FRB brings us one step closer to unraveling this fascinating mystery. The lowest temperature in the universe. While outer space is extremely cold, with an average temperature of about -270 degrees Celsius, there are even colder places. In the Cold Atom Lab aboard the International Space Station, scientists have managed to create temperatures nearing absolute zero, the theoretical limit where atomic motion nearly stops. These ultra-cold conditions allow the study of exotic quantum phenomena, such as Bose-Einstein condensates, where atoms behave as a single quantum entity. These experiments not only expand our understanding of physics, but could also have applications in future technologies like quantum computers. The event horizon, the point of no return. In a black hole, the event horizon is the point of no return. Once something crosses this boundary, it cannot escape, not even light. However, what happens inside the event horizon remains a mystery. According to some theories, information could be trapped in a firewall or stored on the surface of the event horizon, in what is known as the holographic principle. The study of black holes and their event horizons not only challenges our ideas about physics, but could also be key to reconciling general relativity with quantum mechanics, two fundamental theories that do not yet perfectly align. The frigid void of space, extreme cold. Space is not only vast, but also incredibly cold. In the farthest regions from any radiation source, space temperatures drop to a bone-chilling -270.45 degrees Celsius, just above absolute zero. This is the point where atoms almost completely cease to move. Yet, space is not entirely empty. It contains minute traces of gas, dust, and background radiation left as an echo of the Big Bang. This cosmic microwave background radiation, discovered in 1964, remains one of the most compelling pieces of evidence that our universe began with a massive explosion approximately 13.8 billion years ago. The rings of Saturn, an evolving mystery. Saturn's majestic rings are one of the most iconic sights in the solar system. Composed primarily of ice and dust, with fragments ranging from micrometers to several meters in diameter, these rings may be a temporary feature in the planet's lifespan. It is believed that the rings are less than 100 million years old and may disappear within the next 300 million years. This is because the particles that form them are slowly being pulled towards Saturn by its gravity. The rings might be the result of a moon's disintegration or a comet that ventured too close. Auroras, an extraterrestrial spectacle. While we associate auroras with Earth's poles, this phenomenon is not exclusive to our planet. Other worlds like Jupiter and Saturn also have auroras, some even more intense and spectacular than ours. Auroras are caused by the interaction of solar wind particles with the magnetic fields of planets. In Jupiter's case, its auroras are so powerful that they emit X-rays and can be observed from deep space with the right instruments. Cannibal galaxies, the voracious nature of the universe. In the universe, galaxies are not static structures. Many collide and merge in processes that can last millions of years. During these events, larger galaxies often devour smaller ones, a phenomenon known as galactic cannibalism. An example of this is Andromeda, our neighboring galaxy, which is currently on a collision course with the Milky Way, expected to occur in about 4.5 billion years. When this happens, the stars from both galaxies will mix into a new massive galactic conglomerate. Fortunately, the distances between stars are so vast that direct collisions are unlikely. Zombie stars. When a massive star reaches the end of its life, it can explode as a supernova, leaving behind a neutron star. These stellar corpses are incredibly dense, compressing the mass of a sun into a space the size of a city. However, in binary systems, the gravity of a neutron star can siphon material from its nearby companion. This process can revive the star temporarily, emitting intense radiation in the form of X-rays or gamma rays. These zombie stars are rare and provide insights into stellar evolution and the limits of physics. Space is a place full of wonders and mysteries that challenge our understanding and push the boundaries of our imagination. From giant stars to subatomic particles, every corner of the cosmos has a story to tell. And as we advance in our exploration, we can't help but wonder, what other secrets might the universe be hiding, waiting to be discovered? More than 75% of people who watch our videos aren't subscribed to the channel. So if you want to support us, don't forget to subscribe and share the channel so we can keep growing as a Universo family. Don't forget to leave your like and let us know what you thought of the video. See you in the next one. Goodbye.